All right, we're recording. Please be careful for what you say. All right. First one, we're going to start with logs. This is chapter 3. Logs, graphing with logs and exponentials. Just in general, the generic version of an exponential function. I see. 3 to the x minus 2, and then minus 5. Okay. Because I'm using the makeup version, my bad. All right. So in this case, it is a times b to the power of x minus h plus k.
What form is that?
This is will be the generic exponential form. A, h and k works exactly the same as a, h and k works in every other function, where a gives you upside down or upside right, vertical stretch and vertical shrink. H gives you horizontal shifts, and k gives you vertical shifts. B is a little different, unique to exponentials. If b is greater than 1, it is a growth. If b is in between 0 and 1, so like zero point 0.5, it is a decay. B cannot be negative because what will happen is you eventually have a decimal, which is like a square root, and you can't square root negatives. So B just can't be negative. You don't have to worry about that. All right, y-intercept. Y-intercept, that's when you make x equals 0. So you do 3 to the 0 power minus 2 minus 5, 3 to the second negative second power minus 5. In this case, that is going to be 1/9. So that is going to be 4.8 repeating ish. Okay. Negative 4.8
How'd
repeating.
you do that?
So if you do it as a fraction, it'll be 1 over 9 minus 5. So it's going to be 1 over 9 minus 45 over 9, which is negative 44 over 9, which I believe is like 4.8 repeating. Yeah. I just like to put negative 4.8 because if I'm going to graph this, I kind of really want to know where it is. But of course, you could just type in your calculator, you'll get
It's
the
just
value.
after just three tests. Four.
Is that only in the packet? It should be, you're missing the latest one and the one with Miss Carson. I'll do that later on video, but I can't give that out right now because some people have to make it up and I don't have the Carson version. So I have to make my own version and then do it. All right, domain. Domain for an exponential function. I can plug in anything for the x, positive, negative, or whatever. So the domain is all reals or negative infinity to infinity. Soft brackets because you never reach infinity. The range is going to be based off the asymptote. Now the asymptote is just the k value. So the k value is y equals negative 5. So I have a visible line at negative 5 that I can't pass. The range is going to be based off your A value and your K value. Since my A value is positive 1, I'm facing upwards. So it's going to be bigger than 5. I never reach negative 5. So soft bracket at negative 5 towards positive infinity. Same thing as thinking as y is greater than 5. Okay?
Yeah. The range you do a times the
Mm-hmm.
y-intercept, right?
Yeah. To graph, you could plug in points to graph, but hey, you have a calculator. Why waste time plugging in points? Just go to your calculator, type in the equation you have, which is 3 to the power of x minus 2, press right, minus 5. I'm going to graph. Cool, I got a graph. That's nice. But I'll just click my table and it'll make it easy to graph. Wow,
Nah, that's mad simple.
it's going to be like, you use the points that are whole to help you out, but 1 and 4.6. So it's like here, here, and then here, and then here, and then something like here, probably. And then you just make your little curve. So use your calculator. Don't be afraid. Okay. Your log. What is the one on your sheet? Does it have a minus one? So I'll put a minus one here. So your log, same concept. A log um, x minus h plus k. In this case, we're going to get the x-intercept, which makes y, or f of x, equals 0. So 0 equals log x plus 2 minus 1. I'm going to plus 1 on both sides. 1 equals log x plus 2. I'm going to have to bring the log over. If you remember, the base of a log, if you don't see it, it's 10.
LN?
No, the base of ln is e.
Oh, yeah, change to LN though?
No. You can't change it to ln. That's a different thing. It's a natural log. And the natural or the common log, I apologize. The common log, it's a 10 visibly. So I'm going to bring the 10 to the other side. The base of a log becomes the base of an exponent. So 10 to the 1 power equals x plus 2.
Oh, get rid of log.
Yeah. So it's going to be 8 equals x. So my x-intercept is 8. Domain, I'm going to first talk about the asymptote. The asymptote for a log function is your h value. Hmm? No, it does not ask for the y. Yours asks for the y? It should be asking for the x-intercept, so fix that. So fix that. It should ask for the x-intercept.
Values?
It's going to be your h value, which in this case is -2. So x equals -2. I have a dotted line at -2 going this way. And I know my x-intercept's 8. I could put a point there, actually. The range for logs, anything could come out of a log, negative, positive, or 0. So that's going to be from negative infinity to infinity. And your domain is kind of like the range of the previous one. It's based off your h though. So in this case, a is positive, so it's facing to the right. So it's going to be from -2, I never reach -2, to infinity. Generally, your curve is going to look something like this. But again, if you're not 100% sure, you could type into your calculator, get table, and just graph the points. If you remember, exponential and logs are inverses of each other.
Put this in the calculator.
You could. That's a good point.
Doesn't really work though.
All right.
Not so
You would click second graph to get the things. All right, this one, number 3. Now, I don't know if these answers match because I'm using a makeup version, I realize. So some of them match, some of them don't match. Okay. So I'll hold the paper here just in case it changes. So in this case, I could set this equal to x, bring the 4 over. So 64 equals 4 to what power? Hopefully you can see 4 to the 3rd power should give me n. But let's say I'm boring and I just want to use the calculator. Then you could rewrite it with the change of base formula. Log 64 divided by log 4. The change of base formula in general is log. You could do it in the calculator like this. Log base B A. You can rewrite it as log A. Change of base. Log B.
That's a new base.
And I'm sure Monty's not. Is Monty here? Is there a way you could put the base of the log different than normal?
Yeah.
Okay, so you probably could have just put it in the calculator straight through too. So
Log.
you have to remember this one. You only have the basic calculator. I think there's some calc part in the calc. Maybe. Oh, okay, cool. Yes. This will work for even the non-fancy calculators, I guess. And then apparently you could do it anyway. All right, ln e of 9. Because ln and e are opposites to each other, you just cross them out. Your answer is 9. You type that in the calculator, you would also just get 9. Yes. Log base 8, 2. Set that equal to x. 2 equals 8 to the x power. Again, you can use your calculator. But in this case, I'm going smaller. Since I'm going smaller, it's going to be a fraction. So what root of 8 do I get to 2? That'd be a cube root. So it's going to be 1 over 3 as an exponent. Because the cube root of 8 would give me 2. Yep. Number 9. Again, set it equal to x. 1 over 9. Yeah. So 3 to the x power. In this case, I needed to become a fraction. For exponents to cause something to be a fraction, you put a negative exponent. And now I need 3 to become 9. So that's going to be to the 2nd power. So it's going to be -2 in that case. Again, you typed it in the calculator, you should get these numbers.
You can do log 3.
No, you can't do log. Well, you got to find the button for it. Maybe you can. E to the power of ln 7. Again, they cancel out. That's just
Do
7.
a log base.
Negative 2?
Negative 2.
Negative 2.
You can all in.
Yeah, I've been saying. I agree. I agree. Next one, the condense. So condense, remember you got to put this together. Maybe you could put this in the calculator. I don't know anymore. My reality shattered. But because it is adding, that would mean when you condense it, it becomes multiplication. So the answer to this is log 3 times x.
What? Is multiplication?
What's up? Yes, plus would mean, sure. The general rule is log A plus log B. Oh my God, I put log B. Log B, that could be log A times B. If you did subtraction, any guess what that would be? Good.
You just press log. You just press log.
And then the secondary, if you have an x or a multiplier in front, so log AB, that becomes a exponent. So it's going to be log B to the A power. So in this case, this is going to be the half power of x, or ln, the square root of x, y to the third, divided by z to the fifth. Because of the minus sign, it makes it a division. For number 10, you're multiplying this. So e to the third times e to the 11 is e to the 14. This is ln e to the 14, but because it's ln e, you could cross it out, which is your answer is just 14. So that one is funny enough. It reverts back to just straight up adding, actually.
But wouldn't the LNE just cancel out twice and get 3 plus 11?
Yeah, you could do it like that too, actually. All right. Expand is just the reverse of it. So I'll put the answers here so I have space. Looks like the same. So log 14 plus 2 log x, because any exponent should move to the front. For number 12, that's 14. Number 12, 3 log x minus 1/2, because the square root is to the half power, log y. 2, because it's x to the second power, so I got to put it in front.
Because the square root.
Yes, that's why the half part lives. All right. Moving on. Software extraneous solutions. So, for this one, I'm going to bring the base of a log to the other side. That becomes the base of an exponent. Oh, shoot. What's. Okay, luckily it works not too different. So I'm going to bring 64 over to the other side. So x is going to equal to 64 to the 2/3 power. 3 over 2 power. I don't know where the original one went. Or, no, usually because I save it as PDFs. This is the original Word document. So if I change the original, I don't have the original Word document. I just have a PDF of it. So I must have printed the PDF of the OG version, but this is the makeup version where I changed some of the questions. All right. So this case, 64 to the 3 halves. Remember, exponents, if you have a fraction, that is like square rooting. So the square root is 64 to the 3rd power. The square root of 64 is 8. 8 to the 3rd power. 8, 64, 256. This one's not even hard to do in the calculator. You just press exponent to the 3 half power. I could do that. Look, I could just do it in the calculator. 64 to the power of 3 over 2. You're not even, man. They do it for you. The calculator does everything. Yeah, 512. Who cares? You could just use the calculator, guys. Whatever. In this, it will show up in when we have to do some factoring. You remember something like you can't have a negative in the log? Okay. I'll talk about that in detail in a second. So this one, bring the x over. So 64 equals x to the sixth power. So to get rid of the sixth power, I need to use the sixth root. So your problem, you would bring it over. 32 equals x to the fifth power. So you got to do the fifth root of that. Guess what? I wasn't very creative. Both answers end up being 2 anyway. Yeah, 2 times 2 times 2 times 2 times 2 is 32. I guess, or you could literally just put 64 to the 164, 1/6 power instead of guessing checking, you know? All right. Now this one's matching, right? This one? Okay. All right. So this one, because the denominator, or the, I'm sorry, not the denominators, because the bases are the same, you could cross them out. And then you're just with x plus 2 equals x squared. I could set it equal to 0. 0 equals x squared minus x minus 2. Things that multiply to negative 2 add to negative 1. X minus 2, x plus 1. And then your two answers when you set it equal to 0 is positive 2, negative 1. These are exponents. Exponents can have negative answers. So both are okay. So 2, negative 1. If it was in a log. This one's the same. In this one, I know why I didn't change this one because it's hard to actually change. So now I'm going to make this 2 to the power of 2, 5x plus 2 equals 2 to the power of 3, 6x minus 1. Is this annoying? I think this one's basic. 10x plus 4 equals 18x minus 3. A little cleanup. 8x equals 7. So 7 or 8.
Once you have 2 and 2, you can just drop the 2s, right?
As soon as they match, you could drop them. This is your tests. You're right. Yeah. Next one. Number. What the heck is this? 17? Okay, something mismatching then. Wait. Oh, it's just on different. Okay, just I spaced it differently on this one. All right. So this one, bring 5 over to the other side. I can leave in terms of ln and log. So x plus 3 equals log base 5. This would be 17, but it's on the bottom of your page, whereas mine is on the top of this page. As it works the same anyway. So. Yeah, I know. You can tell this is my true masterpiece. You just have the rough draft, I guess. So you can't. If you had only a basic calculator, you can't solve it. And in the multiple choice, I'd probably leave it in terms of log anyway. So then I got to do minus 3, minus 3. So your final answer should be x equals log base 5, 20, because I think yours is 20, minus 3. You cannot combine them. No, you cannot combine them. You don't want the decimal. I'm not asking for the decimal. You leave it in like that. I don't know. I think there's a button, but that's why you use change the base.
Why is it log?
All right. Next one. So this one over here, minus 12, minus 12. 4ex equals 8. Divided by 4, divided by 4. E to the x equals 2. Now, because e, I got to bring it to the other side. Yes. So this is going to be, I got to bring the e to the other side. That's going to be the base of a log, which is ln2. So the answer for this one is just ln2. No, this is algebra. You just rearranging. Just ask Monty first off, then ask me secondary. Okay, how about that? Monty, you busy right now? In this one, it's don't worry about it, buddy. He'll tell you later. 3x plus 2 equals 5x minus 10. Guys, talk about it another time. So, because they're both log 3, you could just cross them out, solve it out. You're going to get 12 equals 2x, x equals 6. No issues there. Remember, you cannot have a negative in your x in your logs. Sure. So, for this one, number 20, this is not one log yet, so I have to combine it first. But because it's subtraction, I don't actually subtract, I divide. So it's going to be ln x plus 4 equals ln 20 divided by 4, which is 5. Now that they're 1 ln each, you can cross it out. X plus 4 equals 5. X equals 1. And the last one, where you actually have to worry about x, whatever this. I think yours is different than mine's. So this is x plus 1, and this is 5, right? No. Okay. Cool. All right. First off, because I have a plus sign here, I'm gonna have to add. I'm gonna have to multiply them to combine. So it's gonna be x minus 3 times x plus 1. So you do have to FOIL. That's end up going to be log little base 2 of x squared minus 2x minus 3. That equals just your 5 on the other side. No. Now we're going to take this little 2 and we got to bring it to the other side. If they both have log base 2, I can just cross them out, but they don't. Remember, when you bring a little 2 to the other side, it is an exponential. So x squared minus 2x minus 3 equals 2 to the 5th power. So 2 to the 5th power, 2 times 2 times 2 times 2. That's 5. That's 5. That's not even. That's 15 times 5. I don't. This is 32. You threw me. So I got to subtract 32 to the other side. So x squared minus 2x minus 35 equals 0. Yeah. So then you're going to multiply things that multiply to negative 35, that adds to negative 2. And good. I heard 10 too. I don't know why. Anyway, 7 and negative 5. Here's an issue though. Negative 5 would cause a negative inside a log. So it can't be negative 5. So it only answers 7. Be for sure, if I made this a multiple choice question, one of the fake answers is going to be 7 and negative 5. No, I don't say that. The only answer works is 7. So I would just say x equals 7. Now radians. Some, sometimes, well, it depends what you're using it for. So I'm going to tell you right now. Okay, buddy? All right, next one. Over here. We need some radians. Okay, so express 240 degrees in radian measure. Since I'm going to radians, I put pi on top. So pi over 180. So 240 times pi over 180. I can simplify this, cut out the zeros. Yeah, this is 4, this is 3. So it ends up just being 4 pi over 3. Change radians into degree measures. So radius to degrees, since I'm going to degrees, 180 is on top of mind, or top of my fraction. 7 pi over 4 times 180 over pi. Cross out the pi's. Do a little bit of math. What do you got? Yeah, that's right. 315. All right. Next one. If sine is 5 over 12, find tangent. So, in some mystery right triangle and some mystery angle, I know from SOHCAHTOA the opposite and the hypotenuse. The opposite should be 5, and the hypotenuse should be 13. I would like to know the adjacent. This is 12. It's a Pythagorean triple. If you don't remember that, you can still use the Pythagorean theorem, which is a squared plus b squared equals c squared. But now I need tan. Tan of theta is opposite over adjacent, or TOA, if you remember from SOHCAHTOA. So in this case, for this particular question, tan of theta is opposite 5 over the adjacent 12. I'm going to put 12 or 5. I mean, there's only so many fractions you can make out of the thing. So,
It's the opposite.
all right. You don't have a triangle? Okay, draw my triangle that I have. Perfect. Oh my god. Yeah, I gave you my draft, which I left. That's the note for myself. Draw triangle for question. Let's go. Yeah, yeah. So this one, number 4. Solve for x in the triangle below. So in this case, we're gonna use some kind of SOHCAHTOA, or you can use special right triangles because it's 30. This is 30, so this is a. This is gonna be 60. So that's a root 3, and this is 2a. Since 2a equals 12, I can confirm that a should equal 6. So I know this side is 6. Since I know a equals 6, I can plug in 6 in here, and I can get 6 root 3. So my answer for this one is 6 root 3. Fake answers, it will be 6, 6 root 2, because if you mess up with the 45, 45, 90, 6 root 3, and then 12. It won't work in calculator because in the multiple choice it will say 6 root 3. Oh, okay, fine. If you did it in calculator, this is going to be your hypotenuse, and this is going to be your adjacent. So SOHCAHTOA, so ka, so that's cosine. So cosine 30 degrees. If you put it in degrees, make sure your calculator's in degrees. Over x over 12 times 12. If you type in your calculator 12 times cosine 30, you will get the whatever the decimal is of 6 root 3. Yeah.
Where do you go?
All right. Now, I think I have number 5 here. Give a reference angle to 700. Sure. So number 5, the reference angle to 700 degrees. Now, first off, in order to calculate the reference angle, you need to know what quadrant you're in. If you're in the first quadrant, it just matches the angle. If you're in the second quadrant, you do whatever your 180 minus the angle you have. If you're in the third quadrant, it's the angle you have minus 180. And if you're in the fourth quadrant, it'll be 360 minus the angle you have. That would be your reference angles. Because you're 700, I'm more than 300, 360. So I'm going to go 700. I'm going to subtract 360 from it. So I'm going to get 340. Now I know I'm in this quadrant in 340. So now I'm going to follow up 360 minus 340 because I'm in the fourth quadrant, 20. So the sine, cosine, and tangent of 20 degrees matches, in the absolute value wise, the sine, cosine, and tangent of 340 degrees. That's what.
We just need the end 20 degrees.
That since I only asked for the reference angle is 20 degrees. Who? What? Huh? What red book? You had the old book from the first half of the year, so you had 2 books. This is the pre-calculus one, the one with the leaves. That's pre-calculus. You didn't get this algebra 2 book. You had a different one. There might be a version in the back, but I'm gonna focus on this. All right. Did I have a number 6? Find a reference angle for. Let me just see if it's. So let me just check. Yeah, sure. All right. So for number 6, same thing, reference angle, but for 9 pi over 3. So in this case, I would change it to degrees to make your life easier and then change it back. Well, 9 pi over 3 is what? 3 pi. If you want to, I'm going to do it in radians, but you could change it to degrees and then change it back because if I give you the question in radians, I'm probably going to give the multiple choice answer in radians. Either way. So 3 pi, this works the same way. If you have the angle here, it would just be the angle. From here, it'll be pi minus whatever your angle is. Your theta minus pi, and then 2 pi minus your theta. In this case, this is too big, so I got to subtract 2 pi. So I have just pi. So it's at this angle here, 180. But that's not in the things. So 180 references to the x-axis. I should say all the axes is referenced. Not this one because I don't like that hit 180. But the reference angle in this case would be 0 degrees because it matches the axes of the other side. That's why. I don't like that it was 180, but in the past it'll be something not 180. All right, number what is this 5? 70, you guys, but it is the same question at least. All right, I want a cosine that's negative 3 over 5, but where the sign is positive. If you remember, all students take calculus. Does this feel familiar at all? Okay. For the cosine to be negative, A and C is where cosine is positive. So S and T is where cosine is negative. And then also, where sine is positive, that has to be an A and S. So the quadrant this belongs into is the second quadrant, the top left. So I know I have some mystery right triangle that kind of looks like this. The theta always comes from the x-axis, so it always comes from wherever the x-axis is. Where cosine is negative 3 over 5. Since my theta's here, that's adjacent, so negative 3 over 5 is your radius, or your hypotenuse.
So it couldn't be in the cosine or tangent because cosine is negative.
Yes. It couldn't be cosine or it couldn't be here.
Cosine or cosine.
Yeah. All right.
So now this is gonna be multiple choice one.
Well, this one, I need to find the hypotenuse, which is 4. In the multiple choice, I probably would give you a specific one. I will say, give me cosecant or something like that.
Let's say it didn't say where sine is positive.
Then you have multiple choices.
Then you have 2 places where it could be.
Yes. That's why I have to put sine as positive. Otherwise, you technically have 2 options for everything. So sine. Well, excuse me. Sine. So sine is positive here. It's opposite of hypotenuse, so 4 over 5. Which cosecant, the reverse of that, is 5 over 4. Cosine, you shouldn't get this one wrong, or you're embarrassing, is negative 3 over 5. Secant over here is a negative 5 over 3. 10 equals. It should be opposite or adjacent. So negative 4 over 3, opposite or adjacent. So cotangent is the reciprocal of that. So that's going to be negative 3 over 4.
That's one you calculate.
You could, but you're going to get a decimal. So you got to make sure to. So tan of 6 pi over 6, you should think of the unit circle. At pi over 6, the unit circle, x, y, y's, is going to be, that is the short one. So it's going to be root 3 over 2. No, that's 30 degrees. Over 1/2. Hold up. If you're putting pi over 6, you should be in radians. Into a trig, you should be in radians. So in this case, it's going to be this. But tan, if you remember, tan is y over x when you talk about the unit circle. So it's 1/2 over root 3 over 2. Because they both have halves on the bottom, I could cross those out. So it's 1 over root 3, but I have to clean that up. So it's going to be root 3 over 3.
When it says evaluate, you just want one answer.
Yes.
Like it's the combination of both points.
I want every answer that fits. In this case, the answer that fits is root 3 over 3.
But this next time you put in degrees.
Basically, a tangent is x over y, so you did that.
Yes.
This next one goes in degrees, right?
That's because of tan. Good
Wow.
question. This one, cosine. This is 210 degrees. This is 210 degrees. This is in the third quadrant. So 210 minus 180. This references 30 degrees. So it's going to be the same as a 30-degree situation. A 30-degree situation is root 3 over 2, comma 1/2. But because 210 is in the third quadrant, it's both negative, okay? Now, since I'm asking for cosine, I want the x value on a unit circle. So I want the x value here. So my answer's negative root 3 over 2.
In degrees.
Ooh.
This would be in degrees.
If you put 210, it would be in degrees.
So when you're given degrees, that degree is value should be rated.
I feel like that makes sense. Yeah. All right. Evaluate cosecant at 3 pi over 4. 3 pi over 4 is in the second quadrant, and it references 45 degrees. So it's going to be root 2 over 2, comma root 2 over 2. But because it's in the second quadrant, that's negative positive. So the x is negative. Cosecant is the opposite sign. So instead of y, it's 1 over y. Yes. So cosecant is 1 over y. Because cosecant's 1 over y, you're going to flip your answer. So instead of it being root 2 over 2, it has to be 2 over root 2. But you got to rationalize. So it's 2 root 2 over 2. But these 2's cancel out. So it's just root 2. Yeah. All right. I'll finish this video on my own time. See you around, guys. Good luck.